duplet. Hello, I am talking about here the central element. I am talking about the central element. See, when we are not in a bonding of only two atoms, when we are doing a bonding of more than two, that means a group of atoms, then there comes a central atom. There comes a central atom. You know, in CO2, carbon will be the central atom. Okay? It is completing its octet, while these two are also completing its octet. But if a different type of molecules where there are 3 or 4 atoms, and you have to find out which one will be the central atom. I am giving you an example, H2SO4. I am giving you an example as H2SO4. See, if you remember or memorize the structure of sulfuric acid, then it's different. But if you haven't memorized the structure of sulfuric acid and it has came to you for the first time, then how will you understand that sulfur will be in the central region? How will you find out that? In order to find out that, you need to know which one has the highest electronegativity. In H2SO4, you are seeing that 4 oxygens are there, 1 sulfur is there, and 2 hydrogens are there. So, the most electronegative element is oxygen. And you have also to find out the least electronegative atom. The least electronegative atom here is hydrogen. So, there will be 1 OH or 2 OH bonds. Now, which one has the least electronegativity? Only sulfur, that is left here. Which one will not the least electronegativity? Which one will have the highest oxidation state? Sulfur, because it can extend its octet. How? Because sulfur has a vacant d orbital, which we will learn from periodic table. Okay? See, now sulfur will be the central element. Sulfur will be the central element. How have we find out? 4 oxygen, most electronegative. 2 hydrogens, least electronegative. And only 1 sulfur. Only 1 sulfur, which has the highest oxidation state. Now, can you tell me how many electrons that sulfur has? Sulfur has 6 electrons, just like oxygen. Sulfur has 6 electrons, just like oxygen. Now, how many electrons will sulfur need to complete its octet? Sulfur needs 2 electrons. 2 electrons are enough to complete its octet. 2 electrons can be provided by 2 hydrogens. 2 electrons can be provided by 2 hydrogens. If hydrogens are provided the 2 electrons, will there be any space for the other 4 oxygens? I guess not. Then what happens? Oxygen also requires how many electrons? 2. Then, see, if I put here an oxygen and I put here a hydrogen, then all the duplet and octet are being satisfied by oxygen and hydrogen. Hydrogen will take an electron from this oxygen, and oxygen will take 2 electrons, one from hydrogen and one for sulfur. See, oxygen has completed its octet. Now hydrogen has completed its duplet. What about the sulfur? This will be a replica here, another oxygen and another hydrogen, right? Sulfur 1 electron, hydrogen 1 electron, oxygen 6 electrons, oxygen completing its duplet. Sorry, oxygen completing its octet and hydrogen completing its duplet. Now, these 2 oxygens are left. 2 oxygens are left. How many electrons are required to complete the octet? 2. Now, as sulfur and oxygen both have 2 lone pairs each. Now, as sulfur and oxygen has 2 lone pair each, which of them will donate to oxygen? It's not up to this oxygen to decide. It's not up to the oxygen to decide. It's up to the coordinating atom to decide. Why? Suppose you have 10 rupees to go from a station to your destination place. You have 10 rupees and the fare of the rickshaw or auto is 10 rupees. A beggar comes to you and asks for money. Can you give him some extra money from yours? No, because that amount will be required by you to travel and go to your destination place. Now suppose you have 5 rupees extra. You have 15 rupees. Then you can give 2 or 3 rupees to that beggar. Just like that. When we are considering about oxygen and sulfur, sulfur has vacant d orbital. Sulfur has vacant d orbital in which it can extend its electrons, thereby increasing its oxidation number. That is why I have asked you which one will have the highest oxidation number between hydrogen, sulfur and oxygen. With that thing, sulfur will donate these 2 electrons to the oxygen and these 2 electrons to this oxygen. The oxidation number of sulfur in H2SO4 will be plus 6. Oxidation number of sulfur in H2SO4 will be plus 6. See how we are calculating the oxidation number and why is it so important? If you don't know about the oxidation number or how it is doing that, then it will be very much difficult for you to understand which one will be in the central and how the atoms are organizing themselves around the central element. It's very hard. I am giving you another example. CrO5. CrO5. Try it by yourself. Try to find out which one will be the central element and what will be the oxidation number of the oxygen and chromium.